recording. And there we go. Hello everybody and welcome to what is, I guess, day 7 of Handmade Hero. It is hard to believe that we have already gone through 7 days, but we have got a lot done. We now have our own window rendering, and we actually have our input working, even on gamepads. Before I get to sound today, we're gonna try and get sound working today. Probably take today and tomorrow, I'm guessing, to get sound working, but we're gonna give it a shot. Before we go to that, I had a couple corrections I wanted to make from the emails that came in. There were some good points that were brought up, and a couple things I just wanted to show real quickly based on the email. I think everyone should see. It's great getting email from everyone. Actually, it's really satisfying because, you know, having more eyes on the code is almost always good. Because people see, catch a bunch of things, and people are trying different things and all that sort of stuff. So first thing I want to point out, someone noticed that, and this is a good idea, is basically that when I wrote these, I was a little absent-minded when I wrote the stub functions here. The stub functions for our fake xinput calls. So when xinput isn't actually found on the machine, and you want to have those stub calls in place so that you don't crash. What we probably want to do here is actually return the error code that says that the devices aren't connected. Because right now we're returning 0, and that's normally, in my world, 0 means that the call failed. But in Windows world, because they do the whole thing where the error codes are actually sort of a series of different integers that can get returned, 0 is actually defined as error success, I believe. So what we'd want to avoid doing is returning a value that would make the caller to the stub code think that it actually had one. Yeah, you can see right here, error success is actually 0. So what we'd rather do is take a look at xinput getState and see what we can return that will make whoever's calling the stub function think that there is no controller, because hey, if the library's not loaded, effectively there isn't. So error device not connected is a better thing for us to return here. That'll result in us working a little more similarly and seamlessly in the case where the stub function gets called. Hopefully that makes good sense. Basically that was just me being absent-minded and forgetting that 0 is my kind of error code to return, not Windows. Windows, 0 means success in that particular case. It doesn't always, but in that case it does. Oftentimes it doesn't. Different parts of Windows are written by different people, so there's not a lot of consistency there. All right, so the other thing I wanted to talk about was right here. Someone was saying, and I didn't actually know this was completely news to me. I don't really have any experience with Windows 8 because I haven't shipped a game in modern times when Windows 8 was around. Last time I was involved in looking at code that was shipping, it was Windows 7. And so basically, this call will actually fail on Windows 8 because it does not have xinput 1.3. It has xinput 1.4 only. So basically 7 is likely to only have 1.3, 8 is likely to only have 1.4. So what I'm going to do here is basically put in a to-do that says, test this on Windows 8 at some point when I can. But also what I'm going to do is I'm going to go ahead and do a layered approach here where I'm going to ask for 1.4 first, because we can use 1.4. And then after that, assuming that we cannot actually load that because it can't find it, then we will try to load 1.3. So basically I'm just going to make it so we try 1.4, which is the more recent version, we try 1.3, and then assuming that we get either one of those, this will evaluate to true, and then we'll be able to get the functions that we want for pulling the xinput device. Now there's 2 other things I wanted to mention, and these are not things we're actually going to fix right now because we're going to get to them a little later, but thing we should mention, sys key up and down, those are actually where the Alt F4 for closing the window comes in. So if you were upset about the fact that your window now no longer closes when you hit Alt F4, that you have to go and use the actual close button, you can actually come in here, and well, I said I wasn't going to fix it, but you know what, I could totally fix it. Let's say you want to come in here and make Alt F4 still close the window. Well, since we are now handling that sys key up down, we are the people who are going to have to choose to handle Alt F4. So if we decide that the VK code equals VK F4, then what we're going to do is we're going to set that global running equal to false to kill our application. But we also need to do one other check here, right? Because we need to make sure that the Alt key was down, right? We need some way of figuring out whether the Alt key was down. So what we're going to do is we're just going to take a quick look over at the actual documentation here, because I believe the Alt key is just in the codes that get passed for this actual message. And so we won't really have to do much work. We'll just be able to look at one of the bits, I believe, and see it. So let's take a look here. Indicates whether the key is an extended key, reserved or not used. The context code, the value is 1 if the alt key is down, 0 if it is not. Let's see. I think that's right. I don't know. Let's find out. That's a little weird the way they have phrased that there, but let's give it a shot. So that is actually in the L param. So the L param is going to have that bit set basically if if the alt key is down. So I'm just going to check to see if that bit is set, and if that bit actually is set, then we're going to see if that BK. Oops, that's not good. Why? Boy, off to a good start to get today, people. I don't even know what I'm looking at here. Let's try that again. You know, some days on the stream, you get a little absent-minded. I tell you, it's hard to always keep in focus. So let's make sure that's right. 29, that's good. So we're just going to check if that bit is down, and if that bit is down, we are good to go. And I'm going to do this guy again, just so we don't get a performance warning on the bool, which we would if we were compiling in another mode. Save that story for a different day. All right, so let's go over to devenv and take a look at what happens when we hit F4, just to make sure that we're actually fielding it properly. Let's take a look here. Off we go. So the first thing I'm going to do is I'm going to hit F4 just to make sure. Oh, no, that did not work at all. What's going on here? Alt key was down, is set to true. That is not what we wanted at all. What am I missing there? I feel like that should not have happened. Am I misinterpreting the documentation? The value is 1 if the alt key is down when the key is pressed. So it should have not been 1. That's a little bit weird. Let's double check, just make sure we're not going crazy here. Could be that that documentation is wrong. Could be, again, that I'm out to lunch on this stream. It's going to happen. If it doesn't happen today, it's going to happen eventually. So let's take a look. You know, we want to see what the W param is. We're taking a look at the 29th bit. So let's see here. So that's not actually set. What did I do wrong? I did something. Oh. Let's see here. I must have done this wrong. Shifted up 120. Ah, awesome. Yep, we are out to lunch today, ladies and gentlemen. So that was interesting. Let's make sure that's the problem first, but then I'm going to explain that, because that's actually a good thing to explain. You may run into that yourself when you're coding. Yeah, much better. So basically what happened there, I'm sure that was going to be easy to miss, so I'm going to go over it a little bit more slowly, because that's a bit of a snafu that you're going to fall into now and again. It's easy to do sometimes. So basically, if you take a look here at alt key was down, what I actually had written, again because of the out to lunchness that we talked about, I had actually written it missing one of the parentheses that I had intended to put. So I wrote it like that. Now in C and C++, there's a thing called operator precedence, which means that certain operators get evaluated first and certain operators get evaluated second, and so on, third, fourth, fifth. Now, we talked about this in the Intro to C stream, and I pointed out the fact that multiplication will happen before addition. Well, the same is true of any other operator. So like this not equals here, and this shift, and this and, they all have precedence too. Now, we properly wrapped our shift in parentheses, so there's no ambiguity. No matter what the operator precedence is, that's going to get done first, so that's fine. But once we get out here, once this is evaluated, you know, so that's equal to something, right? Once that's evaluated, C is going to look at this and it's going to go, the compiler's going to say, well, I've got two operators here, and I've got not equal to. I'm going to evaluate whichever one has higher precedence. Now, in our case, this ended up having the higher precedence. That's just how it's defined. And so that ended up meaning that it would do this operation, eval not equal to 0. Then it was going to AND that with the L param, I guess, is what ended up happening. And of course, since eval not equal to 0 will equal 0 or 1, the L param probably had the low bit set. I don't know if that's likely or not. Let's take a look. The repeat count for the message, so it was probably 1, which is exactly what we would have expected. On the second time through that loop, for example, the repeat count would have been 1. So that will evaluate to true. So all we had to do to fix it was to actually wrap the thing in the parentheses that I was trying to type in before and totally failed to do. So we make that extra parentheses, say we got to do this and first, and then we check for the not equal to 0, which again turns it into a 0 or a 1. And that's something that actually I don't often do, that extra not equal to 0 or 1. Maybe now's a good time to talk about that too, just while we're on this first little preamble. So usually what I do is I don't use bool. I don't usually use bool because bool is defined in C++ to have some kind of odd semantics. Basically, it's defined to have to kind of be either 0 or 1 in some sense. The reason that I say this is because if you notice, when we've got statements that are like this, when we do the bool was down, if I were to get rid of this, and I don't know if this still happens, this is something that at least happened in the old days. I'll show you what happens when we try to compile our code with optimizations on, basically. So let me load up that build.bat file. Where is our build.bat file? Code build.bat. So if I want to do optimizations, I don't know if O2 does optimizations. It's been a long time since I've done that. Maybe not. Maybe WAll does that. Let's see if we've got it here. Here you go. So this is the warning that you will get, basically. It says forcing value bool to true or false performance warning. So basically what that means is if you take a look at what would happen in the case that I wrote here. If you take a look at what would happen here, what it's going to do is it's going to AND the value of lparam with 1 shifted up by 30, so the 30th bit. So the result of this is either going to be 0 or the value of the 30th bit being set. It's not going to be 0 or 1. So if you assign this to a bool, C++ has to generate code that basically checks to see whether the value is 0 or not, and if it's not 0, change it from that 30th bit being set to just being 1. Now the kicker is we didn't care. We were going to do this this comparison here, right? Oh, well, I guess so in this case, no. Okay, I don't feel so bad about this one. I don't feel that we were going to actually do it because we're going to do a not equals here. So in this case, we actually did care what it actually was because we want to be able to compare the two. But in a lot of cases, we don't care. So in this case, for example, we don't actually care. This just has to be something that's non-zero. So we're actually wasting some time by actually doing it that way. So typically what I'll do is I will actually just define my own type there. I'll define basically a bool that's actually an integer. And the bool, so you know, I will do something that looks like this, type def int 32 bool 32. And basically, so the only thing I'm doing there is I'm saying, hey, by the way, whoever's programming this, I intend this just to be a 0 or not 0 value. I don't want to care necessarily about what the value is, but I don't want the compiler to keep shoving it into this 0 or 1 state. So I will often do that, and then I'll just omit this. That's what I will typically do. So maybe we should start doing that because that's what I normally do. So maybe I'll just put that here just so you can see it. That's something that I typically do. There's another thing that I typically do. I don't know if I'm going to do on this stream because it doesn't seem like it's necessarily such a good idea. So I'm going to leave. I'm going to just say that that's probably all we really need to do for now. Have that extra bool in there, and then we'll go forwards from there. All right. We're going to turn off that wall because, man, looks like you really can't compile with wall and include those Windows header files. Those Windows header files are just filled with warnings. Look at all that. I don't know, maybe you got to turn on something else to get that to go away. I'm not sure. That looks new. You used to be able to compile with WL, I thought. Maybe not. Anyway, Windows header files causing a little bit of a problem there. Not much we can do about it, but in the future, maybe we'll just get rid of Windows.h and solve that problem. Okay, so we are now at the point where we should be handling, I believe, our Alt F4 properly. So F4 does not exit, Alt F4 does. That is what we wanted. So I said I wasn't going to show how to handle it, but I did it anyway. There you go. So the reason we had to do that again was just because basically Windows is only going to send you that syskey down message because it doesn't actually know if you maybe had something in particular you wanted to do with the Alt and the F4 keys and so on. So it doesn't want to be presumptuous. So it's actually the def window proc. It's this thing that actually picks up the Alt F4, closes the window for you. So once you start handling WM syskey up and syskey down, then you have to do that stuff that def window proc was doing for you. Now you could just call def window proc, but we don't really want it to do any other syskeys probably. So I say it's better to just handle it ourselves and leave it at that, especially because we may not want a cold exit on this. We may want to do something here. Who knows? So that's probably the best way to do it in my opinion, so that's what we should do. Last point of clarification, down in here, someone brought this up, and they're right to bring it up, but it's just something we weren't going to get to yet. So I want to wait and hold off on talking about it until we get to it. But just so if anyone else is concerned, there is a bug in Xinput, a really bad performance bug. And actually, as far as I know, I'm the first person who actually complained about it. There's a post on Molly Rocket from a long, long time ago where I was like, did anyone else notice the fact that this goes on? Basically what happens is, when you call get xinput getState, if you do not get back a controller, like if there was no controller, remember we're going through all 4 controllers here and polling them. If no controller is plugged in, for that particular index. So if there's no controller 3, there's no controller 4, X input, at least on certain versions of X input, will stall. And it'll stall for several milliseconds or something. It's a really bad stall. It eats up a lot of CPU time. And so you really don't want to actually do this. When we actually do our perf, we are going to have to get rid of this call every time. We only want to pull the ones that are actually connected. Now the documentation suggests doing something that is actually not what I would suggest, which is polling every so often. But that just leads to a spiky frame rate. You don't want to do that. In my opinion, the better way to do it is usually to use the actual HID notifications that come in when devices are plugged and unplugged, because there you can actually see exactly when a device is connected or disconnected. Now, I didn't want to go into that yet, which is why I didn't cover it, but we will be covering it, so don't you worry about that. When we get to performance, we will get to all of these things and they will get ironed out. But just in case you were worried, don't worry about that. Leave it for now. You may get those stalls. They're fine. Again, we are not trying to be on the fast path right now. We're just trying to get everything running so I can show you how to build everything, and then we will start to be concerned about the speed of the various things that I already kind of know we will have to improve when we get there. It's usually best to not crank the, turn that optimization ratchet though until you've got everything working, because your optimization is a very precise, very serious thing that takes a lot of attention, and you don't want to be going at it willy-nilly, and you don't want to be doing it in code that you don't absolutely know you're going to keep, because you're going to waste a lot of time if you do that. All right. That is the end of the clarification, so it is almond milk time, I think, pretty much without a doubt. Almond milk time. And then we will get started on DirectSound. Heaven help us. Okay, a little bit drippy there. That was not the cleanest almond milk take. I'm going to admit that. Sometimes, this is kind of like I didn't type in those parentheses correctly. Sometimes the almond milk gets a little away from you. That's what happens. All right, so basically what we need to do is first, and this is why I say it's going to be a little rough, first I'm even going to do a little sketching here. This sketching is brought to you, of course, by, I think I still have his name written down. This is brought to you by Kurt Karteltepe, in fact, the person who actually sent me mail and told me how to fix OBS so that I could actually run at a reasonable frame rate with tooltips still capturing. And so I think I can actually draw somewhat speedily enough to actually do a diagram here. Yeah, it's pretty bad. Well, I don't know. It's not great, but I'm going to try to draw anyway. It's better than it was, so that's something. All right, so what I want to do here is just give you a little bit of insight in how we're actually going to be outputting sound, because it's a little bit wonky. We're going to be using DirectSound so that we'll have reasonable compatibility with older systems. Like I said, I kind of wanted to show you how to get things running on Windows XP as well, just to show you how to give you a little practice with kind of reaching back and doing backwards compatibility. Does that mean you actually have to target Windows XP when you're actually shipping a game? Probably not. I think the user numbers are down to something like 7%. So it's really not that big of a concern. But I'm trying to keep it that way because there's not a lot of cost to us to actually do that, at least for the majority of the code. So we're doing it anyway. So I'm going to use DirectSound, which is an older API. There are newer audio APIs. I don't think any of them are particularly good anyway. They're probably all 6 of one, half dozen of the other. But you might get slightly better latency and things like that with going with the newer one. I'm not sure. Point being, the way the DirectSound output works, in the way that we're going to be doing it, is basically you allocate a buffer of sound. This is my buffer. This is, the 0th byte of the buffer, and this is, some number n out of there. Wow, this is really slow. Thought it was going to be good, but it wasn't good. And basically, this buffer is circular. So what's going to happen is basically DirectSound, will play along, and it'll play along, and it'll play the sound. And essentially the hardware, whatever your sound hardware is playing the song, and when it gets to the end, it just comes right back around to the beginning again. So it's just going to be constantly looping this buffer. So we're basically going to allocate a buffer that's maybe, it's pretty long, maybe it's like 2 seconds long, let's say. A nice big buffer that's like 2 seconds long. And audio these days, as you can see on most things, is like 48 kilohertz, right? Oh gosh, what is that? What is happening? This is awful. All right, there we go. Audio is basically 48 kilohertz these days, which is 48,000 samples per second, right? So basically we're going to have either 48,000 samples in this buffer if we do 1 second, or we're going to have, what is that, 96,000 in there. Basically we're going to have some large number of samples. And of course what we're doing is we're going to be running this game at 30 frames a second or 60 frames a second, depending on the CPU and all sorts of other system things, the resolution you're running at, that sort of stuff. So we're looking at outputting, something like I want to say like 800 or something like this. I don't know. We're basically going to be outputting 48,000 divided by 60. In fact, you know what? I could actually just do that if I really wanted to, I suppose. If I was being diligent here, 48,000 divided by 60, 800. All right, guess I didn't need to do it. We're going to be outputting about 800 samples per frame to line up with the video, right? Because the video is showing for 1/60th of a second, let's say, and we're going to output 800 samples for that. That is roughly what we're going to be doing. But we cannot, obviously, wherever DirectSound is playing, wherever DirectSound happens to be, let's say DirectSound's, I shouldn't say DirectSound, the hardware is at a particular location, let's say, right? Let's say the hardware is there or something like this. Well, if the hardware is there, we can't actually write directly into there. Because if we wrote directly into there, we would basically have a problem where where it was playing would get past where we were trying to write before we finished writing into it, right? Because there's a bunch of latency in just the writing as well. So what we actually need to do is we need to write a little bit ahead of wherever it actually is, right? So we're basically going to have DirectSound is going to be playing and the hardware is going to be playing somewhere, and we're going to be writing somewhere ahead of it. We're going to write in our new samples that go along with the frames that we're outputting, and then when, actually as DirectSound catches up, it'll just play through those and off we go. So we're always a little bit ahead, right? Now, when we talk about the game loop, when we actually go back and do the full-on game loop stuff, probably starting next week, maybe the week after that, there's a little more subtlety here because it deals with how you structure things. There's stuff to think about, like where you're actually going to do the page flip, right? Because you can imagine if you're viewing some frame, let's say that you're viewing a particular frame that got flipped somewhere around here. So the user is viewing a frame of the video. God, this drawing is so amazingly awful. I'm going to have to tune this sometime. Maybe we'll do a practice stream sometime where I try to get the settings so that I can actually draw. So if we're viewing a frame and we're going to view this frame, let's say this is 1/60th of a second here. So this is 1/60th of a second, right? That's what's going. And it's even Windows that's ruining my stream. It's this stupid. It's that thing. I don't want that thing. That's awful. I got to turn off pen input, I guess. Maybe we'll just go right to the mouse and just do it this way. There we go. 60. So this is 1/60th of a second in here, let's say, right? The user is going to be staring at this picture for that full 1/60th of a second. And so what we're going to do is we're going to be building the next frame. Like in here, in this time, this is where we're calculating the next picture, right? We're doing the rendering and the game updating and all that stuff to generate this picture. So we would also want to output this piece of sound. So we want to output this picture and this sound together, and ideally, we would be writing into the location of the buffer that lines up with where we expect a page flip, right? The problem with this, it's actually really hard to do that because the page flipping happens usually on the V-blank in the old days, but could actually happen anytime now with like NVIDIA's crazy syncing stuff. And there's a deep pipeline sometimes involved, so we actually don't know where these are going to be shown. There's all this kind of stuff that gets in there that makes it more complicated than that. But it's just something to be aware of, like trying to think about the audio sync. On any given frame, you're computing the picture that's going to get flipped at some point, going to start being shown, and the audio that's going to play behind it, ideally. And that's kind of the way to think about it. So basically what we're going to try to do today is just open a handle to DirectSound and get this buffer up, this thing where, and have DirectSound just kind of do this infinite loop on it where it just plays it over and over and over again. That's where we're going for. I don't know if we'll get it today, but that's where we're going for. So hopefully that makes some sense. It's pretty straightforward. And again, it's just memory that we're just writing into, just like the bitmap. It's the exact same thing we did with the bitmap. We're just open up a buffer that we can write our own sound into, and then that sound will just play out the speakers, which is what we want. I'm just going to close this awful GIMP because that was horrible. I got to figure out what's wrong with that before. Someone email me and remind me if you think about it. To fix that, because that drawing was horrid. Okay. So, what we need to do here, if I remember correctly, and we'll have to look at the docs, but if I remember correctly, you can't really get your DirectSound going, I think, until you have a window. So basically, we don't want to do it up here. We can load X input, we can load at any time, so that was a good time to do that, but we can't actually do that with DirectSound. I think we want to do that a little later. So basically down in here, after we actually know that we do have a window and the window is actually open, then we're going to do a Win32, I guess we're going to call it load dsound, because we got to load it and then we also got to open it as well. So we'll basically call it that. Maybe I'll call it Win32 init DSound because to some degree that's a little more accurate since we're doing more than just loading it. So anyway, we're going to have this here. Maybe it'll return something eventually, but basically we're going to have a little function here to initialize DirectSound. And what that's going to have to do is it's going to have to do a couple things. So the first thing that we're going to have to do is we're going to have to actually load the library, which is what we did before, right? We're going to actually load DSound up because, again, you know, if for some reason DSound wasn't installed on the machine, it's unlikely, but let's say it wasn't, there's no reason to not be able to play the game. You'd have to play the game without sound, but at least the game will still run. So we don't want to say that you have to absolutely have DSound. So we're going to have to do that. Then we're going to have to get a DirectSound object because basically DirectSound is object-oriented. That is the way they chose to implement it, unfortunately. It's kind of a COM, it's this thing, the component object model. It's a whole thing in Windows that I'd rather not actually have to go into if we can avoid it. So it's just a nightmare. It's basically a thing that they decided to do that was about trying to sort of have an object-oriented model for how things are called in Windows and where you can ask about what interfaces things support and all this kind of jazz. It was a complete train wreck. Awful, just absolutely awful, bad idea. But unfortunately, that is the way that these APIs were exposed at the time. That's just how they wrote them. They were not clean like the Xinput one where you just get a couple calls and it works. This is a lot messier. So we're going to have to get a DirectSound object. We are going to have to essentially create a primary buffer, which is basically sort of it's holdover from the original version of DirectSound where you wrote directly to the sound card in some sense. They don't really let you do that anymore, but you still have to create a primary buffer, which was supposed to be the thing that was on the sound card, so that you can set the mode of that in the old school way of doing things. And then we're going to create a secondary buffer, which is the thing we're actually going to write to, if that makes sense. And then after that, we will just start it playing. And then we should be good to go. That should actually give us sound on Windows in theory, if I'm not forgetting a step. And in here, there's a couple things like there's a cooperative mode that you have to set that just kind of tells it what you're doing and these sorts of other things. All right, so first of all, we need to load the library. We already know how to do that. We're basically doing that exactly the same way that we did it for Xinput when you look up here, right? We're doing that exact same thing. So we're just going to load library dsound.dll, if I'm not very much mistaken. We're just going to go ahead and load that up. And then assuming that we actually find the library, then we're going to do these additional steps here. So in order to get a DirectSound object, I believe we have to get proc address on DirectSound create. So basically this thing right here that we were doing, this sort of situation from before, we got to do that, and I think it's called DirectSound create. I'm going to take a look and make sure that's actually true because I don't remember a lot of these things by heart. I gotta be honest with you. So DirectSound create, much like I was doing before, I basically want to verify all this with the actual yeah, this is it. With the actual documentation. Now, fortunately, this isn't the actual documentation. This is someone asking about the actual documentation. That's DirectSound Create 8, which I didn't actually want because we don't want to require 8. We have absolutely no reason to require it, but it doesn't look like I've got a lot of other reference here. This does actually look right, but I'd rather read the actual documentation. That's a little unfortunate. Well, what are you going to do? I guess we'll muddle through this the old-fashioned way. Like I said, it was going to be rough. We're using an older version of the API, which means you kind of end up in some sticky situations sometimes. So let's go ahead and include dsound.h here, I guess, and make sure that we actually have it, and we do, so that's good. And then I'm going to go up here, and I'm going to just go right ahead and open that up. We'll just say, let's see what it's got in it, because that'll help us out. So let's take a look at DirectSound Create. Here we go. This is the actual call that we wanted, looks like. So I'm going to cut and paste that out of here, and I'm going to go ahead and do our standard get proc address maneuver exactly the way that we did these guys. So I'm going to say pound define h result win API, and then we're going to do a name here, and this is basically our direct sound create, and so we give it a name, and that will initialize it right there. It's going to take one of those, it's going to take one of those, and it is going to take one of those. Now, One of the things you may ask me to do, and I don't blame you, is to explain to you what these extra things are, like p-unc outer, and I am perhaps disappointed, perhaps pleased to say I have absolutely no idea. I know it has something to do with the COM interface thing, that weird old thing that used to do, but I have never actually had to use those things. I have never had to use that pointer for anything. And so I'm happy to say I have just always left it 0. I'm sure it has an explanation. I'm sure the documentation will tell you if you're curious, but I can't tell you. The GUID device, on the other hand, is pretty straightforward. That's just what sound card you were trying to open. We're actually going to pass 0 for both of those. But anyway, so here we go. This is the thing we actually need to get that back. So we're going to call DirectSound create, and then we're going to do exactly the same things that we did here. We made our macro. We're going to make a pointer to it, basically, DirectSound create. We are going to make, well, we don't actually need a stub call, actually, because this isn't going to get called from anywhere. We don't even need it to be global, actually. We just need the type def, because what we're going to do is we're just going to use it to create it just that one time. So we actually only need the pointer in here. We're never going to call that create again, I don't think. Now, if we change our mind, we can always move it out to be a universal function that's called, but since we don't need it universally yet, I'm not going to bother putting it universal, because that'll only lead to maybe people calling it accidentally, or who knows what else. So if we get the library, we'll go ahead and do the DirectSound create call, and we'll make sure we actually get that back. Assuming we get that back, then we will actually try to call it like this, I guess. We'll just go ahead and call it right in here. If we don't get it back, this might be a good place to just give a quick diagnostic. And I'm going to just put these in here because we'll eventually have a logging system where we'll log errors. And so I might just add those in there so we know. And I'm going to put them up here as well, just so we kind of know. This might be a good place for a diagnostic as well, just so you know which version of X input was running in case there's stuff. You know, we might print out kind of which version we loaded, that sort of stuff. You know, these might be good, that sort of thing. So just kind of put some to-dos in there so that when we come through here, when we do have a logging system, we can add them in. The code will still work just fine, even though we don't have diagnostics. Those are just for error checking later when we're trying to do compatibility testing. Sometimes it helps to have some way of like looking at a log and seeing what went wrong. Okay, so I got to set the cooperative level here. I'm pretty sure that's what we do. Oh, DirectSound create. We don't care which device it is. We need to create one of those. Basically, the way that it works is we call DirectSound create, and it's going to give us back a return code that we're going to have to check here. And then what we're going to do is we're actually not going to. It's not going to return to us that DirectSound handle. What it's actually going to do is it's going to give us back the pointer in an out parameter. This thing right here, this LP DirectSound. So basically, what we're going to have is we're going to have a DirectSound object. Right, we're going to have a DirectSound object pointer. So basically, this is DirectSound, right? Like that. We're going to have this DirectSound pointer, and we are going to pass it the address of that pointer, and it's going to fill in the address, assuming it was successful. Then it's going to return this H result, and because of the way they decided to do this in DirectX, you have to use this macro. This macro succeeded to see whether the thing actually worked. It's absolutely ludicrous. It makes no sense whatsoever. They were just making things worse as they went, but that's what happened. And you can actually see what it is here in the actual things. I think it should be defined, although it's probably actually defined outside of here. I don't know how to actually show you where it's defined because it's going to be up in some kind of other API definition. But basically all it's doing is it's checking the return code of this for a specific value, like the kind that we were doing before when we said we had to check for that device not connected kind of a thing, this sort of a thing, and error success. Remember that? It's doing that kind of check basically. But I think they managed to make it even more complicated than that potentially. If you're curious, go look it up. Do a grep in the files. But basically that's all it's doing, figuring out whether the DirectSound create call actually worked or not. So assuming that we actually do get one back, we got to set the cooperative level. And so set cooperative level, we can also just get right out of here. Set cooperative level. So there it is. These are the methods. In fact, you can see here, this is the interface. This is the iDirectSound interface, actually. That's it right there. So actually, that's interesting. I wonder if this is... Yeah, does this actually compile properly? No, it doesn't. So what is the actual... Let's take a look here. Type that we should be using. Is it just iDirectSound? iDirectSound 8. I'm not entirely certain. LP DirectSound is any direct sound, but what is this actually defined to be? Is this just always defined to be 8? I'm just trying to figure out which type of object we're defining here. So there's an iDirectSound, and then there's a, yeah. I'm not certain. I am not certain about that. So I guess we'll just use their actual definition. I'm trying to decide what would be, basically what I want to know here is, what's the most proper way to actually do this? LP direct sound is a pointer to a direct sound, but I was wondering what direct sound is defined to point to exactly. If it's designed to point to a specific one, or if it's designed, yeah, I was a little hazy on that. Like I said, it's been a long time since I programmed anything like this. We should be fine because we don't actually call anything specific. We're just calling the very generic direct sound stuff. So I guess probably the best thing to do is just to use the type that they originally defined, which is LP direct sound, which is just saying a pointer to a direct sound object. And we'll pass an address to that. And if the header happens to define that to only be 8, that should be fine for our purposes because 8 ships on Windows XP, I believe. So we should be good to go with everything. I don't know if we need, for some reason, direct sound 7, but I'm not sure. That's something we'll check. So maybe we'll slap a to-do in here and say, double check that this works on XP. Direct sound 8 or 7 because we're not actually sure, and I think we're going to want to actually test it so that we'll know. Conjecture is not going to work for a lot of these things. Windows compatibility is always a lot of fun. All right, so anyway, if we're going to go do the we don't need to do that. We need to do the set the compatibility mode thing that I was saying, set cooperative level. So set cooperative level, I don't think there's anything special that we have to say. We're just going to set the normal level, but I think you have to do it. If I remember correctly, I don't know if that's actually true anymore, but I'm pretty sure you have to actually say this and say which one you're going to do. And so we don't actually need anything in particular. Oh, you know what? Okay, so we actually do. So if you look here, normal is what I was saying. Oh, maybe we just do normal, but I don't think we actually want to do that. What we want to do is do priority probably so that we can actually set the sound output format to be equal to the format that all of our sounds are in. Like I said, we want to do 48 kilohertz probably, and we want to do like stereo 48 kilohertz, something like that. So we want to be able to set the sound card to be outputting in that. Now in the old days that mattered. I don't know if that matters so much anymore because it may be that all this stuff just goes to the kernel mixer anyway and it all gets munged and all that stuff is fine, but we're at least going to do it in a way that was correct at the time. So we're going to go ahead and pass that priority as well. So as you can see here, like I was saying, there's actually a oops, that was not the right thing to copy. It's the window. So we're going to need the window handle here. If you remember, I was saying we actually need to have a window up before we do the things that we want to do. So that's exactly why, right? We've got to tell it what window handle we are so that when we tell it we want priority, I guess it ties that to the window handle so that when our window is active, I'm assuming, basically what it does is when our window is active, it'll make sure that the sound card is playing in that format and so on. So we're going to do that. I don't think we're going to actually check that return code because honestly, if it can't set it, there's not really much we're going to be able to do about it. So what we could do is we could go here and say, you know, if it didn't succeed, if it didn't do its succeeded thing, then, well, or I guess we'll do if it succeeded, and then else we'll put a diagnostic here just so we can say, oh, hey, by the way, we weren't able to set the buffer format, but we're still going to continue with the rest of the stuff we were going to do. So if we want to set the buffer format, I think that's where we have to do this primary buffer thing. So I'm going to go read the docs here because, like I said, don't remember this stuff that well. But yeah, so we're gonna take a look at how you actually do the create buffer here. Let's sync this. I'm assuming we can sync this for iDirectSound 8, and we should be able to get all the calls that we actually have to call. So basically, I think what I want is just create sound buffer here. I think that's all we really need. And that's basically another one of these kind of semi-generic calls. It's going to pass a buffer description. It's going to give us back. It's exactly analogous to this call right here. We pass it in a pointer. And I'm not sure if I need to create the primary buffer if we can't set the format. So I'm going to do it in here for now, but then we'll take a look. So basically, we're going to try and create this buffer. We're going to have a pointer to a direct sound buffer. This is the primary buffer. We're going to pass that in, and it's going to give us back the pointer. Again, we don't need that unc outer. That's COM, more of that COM nonsense we don't actually need, but we probably do need the buffer description. That's something that we actually do need to do. So we're going to have to define this buffer description here, and we're going to have to give that a bunch of attention because I think it's got a number of members in it. So assuming that we can create this, and I believe this is another succeeded if I'm not very much in error, then we'll be able to set its format. So in the DS buffer desk structure, it's got a few things. It's got the size, so primary buffer.dbw size, and the size is basically just equal to, well, you know what? Why am I doing it in here? That's the wrong place. I'm probably going to use a little trick here, I think. So I think, if I'm not very much mistaken, let's take a look. I think they often tell you got to zero these things before you actually use them. I'm not sure if that's true, but I feel like they often do. Yes. Application, no, well, no, that's not it. Let's see here. I'm gonna look at the web at large. So let's take a look at create sound buffer and zero struct. I feel like, or whatever, zero memory, I think it's called. Let me take a look here. I believe that this is the convention that you always have to actually do. Yeah, it does. So I don't know why they didn't say this in the docs, but they almost always force you to do this. They force you to clear the thing to 0 before you actually pass it. They always say to do this, and they do it in all their docs. I don't actually really know why. I think it's so that if they extend the structure later, your code won't break. You'll be able to recompile it, and it'll just work and clear the extra things to 0. I'm not really sure, but basically I'm going to cheat and do a little shorthand here. Since the size is the first member always of the structure, I'm just going to go ahead and do this. Because basically what that'll do is that'll stick the size of the thing in there, and then it'll clear the rest of it to 0. Off we go. Lovely, isn't it? It's kind of a bit weird, but might as well do it. All right, so then we got the flags. Let's see if there's any flags that we think we need to set. In here, let's see. 3D we don't need. Frequency control we don't actually need. Effects processing we don't need. We don't need pan. We don't need volume. We don't need position notification. We don't need global focus. Let's see. Let's see. No, not well. I mean, I don't know. Do we want global focus? Do we want the thing to keep playing? Probably not. I don't really know. Well, we could think about that one. I'll put a to do in there to take a look at that one. I don't actually know. I don't recall ever using that one, but maybe I did. I'm not sure. Let's see if we want that one. Lock defer to a hardware resource that play. The buffer can be assigned to hardware or when this is called. I'm not sure about that one. We don't care about these, whether they're hardware or software. I'm not sure why we would actually have to call those. Primary buffer, that one we do need to call because this is the primary buffer. So that's one of our flags for sure. And let's see. We don't know whether it's on board. Sticky focus. So auto roll, position direction, the buffer is muted. True play position. To return the bar's true play position, only valid in Windows Vista. All right, I don't know. It's a bit of a crapshoot here with these flags. We may have to play around with them a little bit. Not a lot of great documentation there. Anyway, the size of the buffer in bytes, again, pretty straightforward. That is, again, like I kind of explained in the diagram that was drawing extremely slowly because of GIMP. Basically, what I want to do here is I want to allocate about 2 seconds worth of audio. So what I'll do, just to be a little bit more flexible, is whoever actually calls this can decide what that's going to be. Now, my only question, though, is I don't know whether I need to do that on the primary buffer or the secondary buffer. I think you want to do that on the secondary buffer. So I think the primary buffer is actually going to be set to 0, would be my guess. Let's double check that and see if that's actually true for the primary buffer. Okay. The DB flags member contains the same flags used by the buffer. The only difference is the DSCast structure, blah, 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 according to the location of the buffer. These flags are optional, used to force either hardware. Okay, yeah, so we don't need any of those things. What about this guy here? What does this guy say? When creating primary, actually the buffer bytes member to 0. Okay, that's what I wanted confirmation on. So basically on this guy, that's still going to be 0. That's going to be something that later when we create our secondary buffer, the secondary buffer will set this equal to the buffer size, basically. So we're going to pass that in. Someone else can tell us what our buffer size is. So basically, we don't have to worry about that at all. So in the buffer desk, back here on the buffer desk, let's take a look. We have a format, an address of a wave format EX for specifying the format for the buffer. This buffer must be null for primary buffers. All right, so again, all null. So it looks kind of like basically the only thing we're setting here is the size and the primary buffer caps. That's a bit odd. I don't know. I'm also thinking maybe I want to do this. This is not how I normally do it, but I'm thinking maybe I want to do it like this, just to be a little more careful. Just because that way, if they move the DAW size parameter someday, we'll be in good shape for that as well. If I just stick it in here, then maybe they could rearrange the struct. I don't think they ever would, but just in case they do, maybe it's a bad habit to show people. So let's just leave that like that. Okay. So I think that's all we actually needed to fill out according to the documentation. Seems a little sparse, but who knows? I guess we can see whether we got it or not. Again, we're only creating this primary buffer so that we can set the format on it. Once we actually create it, I believe we can call the function. There's literally a function called setFormat, and it's on the actual buffer. So when we get back this buffer, excuse me, I think there's just a call that allows us to set the format that it is playing in. That's getFormat. That is setFormat. There we go. And so if I want to call setFormat, there's the primary buffer. We'll call setFormat. On waveFormat EX is the thing that it wants. So we got to fill this out here. So there we go. waveFormat EX. waveFormat. That, again, we're going to go ahead and initialize that to 0 because that seems to be what they want us to do to everything. Can't hurt. This is not performance code at all. Clearing things to 0 can only help us avoid bugs, so you might as well do it when you don't care about the cycles. So there we go. And then we will call setFormat with that. And there we go. All right, so WFormat tag, that is the format. Basically, they only support one, it looks like, for our purposes, which is the PCM format there, which is basically just the straight ahead audio, 1 or 2 channel PCM. That's what we've got. I assume that's true. I assume. That's what we're going to go with for now. Again, like I said, it's going to be rough with audio. So many things to set for such a simple thing. Channels, I think we want stereo sound. At the very least, we want to play our music in stereo, but we'll probably also want our sound effects to kind of maybe pan a little bit, that sort of thing. Samples per second, again, we're going to let that be passed in probably, just in case it wants to be configurable. No sense in forcing that when we could make it parametric, just in case we want to change it. Average bytes per second, that seems like it's just going to be however big, however big the buffer is in that many, however many samples per second times the number of seconds. Seems like that would be, well, and times the size of the thing. So let's take a look here. Bits. Let's finish this out. Bits per sample is the number equal to 8 or 16. So basically, per sample, we can decide whether we want 8-bit audio or 16-bit audio, and we're going to use 16-bit audio. I mean, that's what a CD is, right? Everything is 16 bits in audio, and we'll kind of, I don't really want to get too much into how sound is recorded yet, because we're going to talk about that when we actually write our mixer, which is where we're going to be dealing with sound samples a lot more. So suffice to say, just like a CD, we're going to use 16-bit audio. Not 8-bit audio, because why not? Might as well get it the extra resolution. It'll sound nicer. The block alignment is the minimum atomic unit of data for the WFormat tag format type. Block alignment equal to the product of n channels and bits per sample divided by 8. So it's basically just the number of channels we have per sample, right, which is 2, left and right channels per sample. They're kind of packed in there, times the bits per sample. So that is how many bits there are for a full sample, one for each channel. So it would be 32 bits. And then we're going to divide basically by the number of bits in a byte. So that's the calculation it wants to do. So just to be more explicit about that, basically what we're doing is we're creating some memory, and we're going to write samples into it. We're going to write int16 samples in, 16-bit samples for our audio. And those samples are basically the waveform. They're how high the waveform is at that point of the sound, right? So just like, it's basically, we're making a little graph of the waveform. And so basically we're going to write int16s, and we're going to write them in like left, right, left, right, left, right, like interleaved like that. We're not going to have 2 separate buffers, one for the left channel, one for the right channel, it looks like. We're just going to, there's nothing wrong with that as well, but it looks like this is the way they want us to specify it in here. So this is the way we're going to do it. So basically what they're doing is they're basically asking us to do the computation of how many bytes per sample there are. And the number of bytes per sample is the number of how many bytes per single unit of the channel. So including the left and the right. So basically in this thing where we were like left, right, left, right, left, right, they wanted us to say how big is this in bytes, right? And so if this one's 16 bits and this one's 16 bits, You add those together, you get 32 bits, and then they wanted it in bytes, so we got to divide by 8, right, which is going to basically be equal to 4. So all that is going to boil down to 4. Then what they want to do is they want the n block align times the samples per second for the average bytes per second, right? Because however many samples per second there are times basically the size of one whole sample. Yeah. Although the odd thing about that is they're kind of mixing words there if that's actually true. Because if they're calling a sample, in here they're saying there's a 16 bits per sample, but really they mean 16 bits per half a sample in that sense because they're only talking about half the channel. But I'm pretty sure what they definitely said it, at least in the documentation. They said n channels and bits per sample divided by 8. So that's kind of mincing the words there in some sense, I would think. I don't know about that. I don't know about that. It's a little bit hazy. I don't love it. I don't love it, people, but that's what the documentation say. We have no extra information appended to the end of this. We don't have an extension or anything, so we're going to get rid of that. So basically, we have one problem. If we fill out the structure in order, of course, Microsoft did us the favor of basically making a bug. If we actually fill out the structure in the order that they told us to fill it out in, well, we've got a problem. We're referencing block align before we actually write it. So we got to flip that around in order to make it so that block align's actually filled out by the time we actually need it to compute the average bytes per second. Okay, so then we're going to set the format there. We're going to set the format on the primary buffer, and I believe that that's all we actually have to call is just that, give it the pointer. And that's going to do succeeded as well. So there we go. We're going to basically have diagnostics everywhere here because there's so many things that could fail. That is one of the things that you absolutely don't want in APIs is tons and tons of failure points, but Microsoft has that in spades, unfortunately, and we are left to deal with it. Basically, every game programmer is left to deal with it. What can you do? Okay, so in here, now we have finally set the format of the primary buffer. So that's a good thing, and we'll be leaving that. And then we are going to, and I should actually put in the comment that said we were going to do that. It was up here, create the primary buffer. Then we are going to go ahead and create the secondary buffer, which is the buffer we'll actually play in. So really, again, the only reason for all of this stuff was literally just to make it so that we could set that format so that we wouldn't be doing any upsampling or downsampling. Now again, I think the kernel mixer just does that stuff nowadays, so I'm not sure that it's actually helping on anything other than older machines. It's probably not actually doing much on newer machines, but what can you do? All right, so to create the secondary buffer, it's the exact same thing, nothing particularly odd. I think since we basically want the exact same format in both cases, I'm going to go ahead and promote this guy basically out to here so that we actually have the same thing when we go to create this buffer. Now, I don't know, the other thing that I'm wondering is if you can just duplicate the primary buffer, because you'll notice there was actually a duplication call here that basically allowed you to say, hey, I want a copy, duplicate sound buffer. So I think we might actually just be able to call that. Let's take a look. What does it say? The duplicate sound buffer memory creates a new secondary buffer that shares the original buffer's memory. No, all right, so that we can't do. That's no good. That is not useful. All right, so we're just going to have to create it anew. It looks like that's not a problem. It just means we're going to have to use a different buffer description here. So here in the secondary buffer, we're going to have to pass a different buffer description. That buffer description will presumably have more things filled out in it. So then we're going to go ahead and pass that, get that going. Do the succeeded. Oops, that's no good. Do the succeeded and then the set format. Well, we won't have to do set format this time because I think we can just pass it in the buffer description. Because remember, the reason we didn't do that before was basically just that we, excuse me, just that we couldn't actually say to the primary buffer that we actually wanted it, that we had to use the set format call. It's just the way it was defined for no apparent reason. All right, so in here, if we can create our sound buffer, I'm going to actually start it playing as well, which will be kind of amusing. It'll just be complete silence because we'll probably clear the memory as well. Oh no, you know what? We won't have locked it yet. So we'll probably want to do, we'll probably actually want to have a second call to start it playing. So I'm actually not going to do that. I'm going to hold off on starting playing. We're going to put that somewhere else. So I'm going to go here and just finish our secondary buffer description. I'm going to take a look at that buffer desk again and see which values we want in the secondary buffer, because obviously there's a bunch. Oops, that's not it at all. Buffer desk. Why are you not getting found, buffer desk? Where are you? You are not there. All right, well, that's fine. I'll just look at create sound buffer, and then we'll get it off of that, because that's easy enough to do. All right, so here we go, DS buffer desk. Oh, that's why, because I've named it wrong. That was my fault. That was entirely my fault. Those should be DS buffer desk, looks like. Looks like to me. Okay. So basically what I'm going to do here is I'm just going to double check to see what values we need, because we are not the primary buffer. So we're going to have to set the flags, get the size, and the wave format. So it looks like, oh, yeah, see what I said? I knew we wouldn't quite get it all done today. We're pretty close though. We'll probably get it done tomorrow, depending on whether we hit some bugs or not. You never know when those bugs will happen. All right, so we got a buffer description in there. And basically we just got to set these flags to something that's useful. That seems like the primary thing that we're going to have to do. So the caps, let's see, in the flags, we don't want 3D or frequency. We didn't want any of these things. We didn't want any of that. We didn't want current global focus. Maybe. I don't know if we wanted global focus or not. We still don't know. Lock defer, don't need any of that stuff. Static, don't know if we want any of that. Sticky focus, I don't know that we want any of these. It doesn't really look like anything we care about. The buffer uses a new behavior for the play cursor. In the first version of DirectSound, the play cursor was significantly ahead of the actual playing sound on emulated sound cards. It was directly behind the right cursor. Now, if the flag is specified, we don't care because we really only need that right cursor, probably. Yeah. All right. Well, I don't know. We could think about using that for potentially some accuracy purposes. So we'll just drop that in there. But it looks like we don't really need much in the way of flags. We might not need anything. So let's take a look. All right. So create sound buffer. Oh, I just forgot. That's actually off of the DirectSound object. That's just that's a method call. So we gotta call it off of there. DS buffer desk. Let's see. Cannot convert it to. Oh, that's great. That's not the right thing. I meant wave format. There we go. Again, static typing catches a lot of bugs for you. We have to pass the window handle here. And then, oops, that is not what I wanted to do. We don't have an H file for that yet. Then I want to go double check. Let's see, what is that went through to init D sound. I want to pass the samples per second, which we said for now will be 48,000. And the buffer size, which I guess will also be, let's see, that times the size of an int16 times 2. So we'll just ask for that now. We'll kind of deal with how we want to do audio startup farther in the future when we actually know what's going on. But there we go. We'll actually try the init. And before our time is up, we can at least run it and see if we crash a horrible death. See if any of these calls actually work, and so we'll kind of know what kind of shape we're in for tomorrow. Well, we got the library. That was good. We got a handle DirectSound create. It looks like we actually got the DirectSound create as well. The cooperative mode was set properly. We succeeded in creating the primary buffer. Well, I should have put something in here so we could actually see if that succeeded. Unfortunately, we may be out of register now, so I don't even know. We'll fill this out and that one. All right, so the only thing I'm going to do just before we run out of time completely, we only have about 3 minutes left, so I'm just going to print out a diagnostic directly to the debug just to see if these actually worked. So output debug string A, primary buffer format was set, and then here also we will say secondary buffer created successfully. Spelling. All right, there we go. And let's see how we did, if those both actually worked. Let's take a look here. No, I do not see anything there, ladies and gentlemen. I don't know about you. I did not see anything. So that does not fill me with confidence. We may have still, it went so well there at first, but it didn't actually work. All right, let's take a look here. So we went in here, that succeeded, but that did not succeed. So set format did not actually succeed. And maybe I'm totally wrong that you can even do that. And that did not succeed either. So we were unable to create that buffer format. So we still have some problems. Basically what I'm going to go ahead and do then is I'm going to print out what the error code is just so we can see it. And then again, like I said, we'll kind of know what shape we're in. I'm sure we just have a couple things set wrong. There was a lot of stuff we had to fill out. So as you can imagine, there's a lot of accidental things we probably set wrong. Maybe some of you even caught them on the stream, and in which case it'll be easier for us to debug later. But basically, if you didn't, it's okay. We will be debugging it tomorrow, and I think we will have plenty of time to make that work. So I'm just going to pull this out here so we can actually excuse me, see what those error messages are. Again, so that way will maybe give us a little bit of a hint as to what we did wrong among the myriad of things we might have done. Yeah, so that fails. So basically looking at that, oops, that's no good. Looking at that error code, what is that error code? The error code is invalid arg, one or more arguments are invalid. All right, great, that's awfully specific. That doesn't really help us at all. How much you want to bet the next one is the same, and it is. So basically all we know is we filled out something in the structures incorrectly. That's about all we get, and we're not going to have a lot more to go on now. Hopefully it's just something real simple. So, you know, again, like I said, it's been a long time since I've done this. I will go like double check my own code. It's probably just something really simple. So we should have no problem getting sound up and running tomorrow. That's the good news, because this is basically all the work there was. Once we get this loading properly, then you can go ahead and use the lock command to just write the sound buffer, and sound will play. And that's most of it right there. Again, not a great API, it is true, but the thing I want to keep emphasizing is, man, you know, it's that many lines of code. You know, a lot of people, they always say it's so complicated and why would you write it yourself? But at the same time, it's like, man, how long does it take to just write that function? I mean, that is just not that long. We'll have it debugged and running by tomorrow. You know, I don't know, if I wasn't explaining things on the stream, for example, how much a time investment is that? 30 minutes? An hour? You got to debug it the first time maybe, so maybe figure even a day, but then you've got it forever. You never have to use 8,000 different libraries and all that sort of stuff. So it's just, you know, I just want people to understand, I guess, and I try to keep hammering home, while it's always fine to use engines and libraries, and you should do whatever makes you the most efficient when you're programming, I also think that people need to be more realistic about actually how little work there is in doing some of these things. You don't really need to be that afraid of writing your own platform code. It's a couple of weeks of work per platform a lot of times. It's really just not that big a deal, and once you do it once, you're in a very good position to maintain that going forwards. You know, sometimes they'll come along and they'll do something like Windows 8 that really screws you up, but a lot of times it's fine and you can just keep on rolling. And nobody plays games on Windows 8 anyway, so you don't even have to care when stuff like that happens a lot of times. So that's a benefit as well. So anyway, that is it for Handmade Hero today. We are going to do some Q&A now. That is all the code that we will have time to get in there. But I think it went pretty well. There wasn't a lot of a confusion there. And actually, we had very few errors in the actual call, so I think we'll be able to debug them really quickly tomorrow. So be sure to join us again. Tomorrow is going to be, since today was Tuesday, tomorrow is Wednesday, Thursday, Friday are basically the Thanksgiving holiday here in the United States. So we're going to be streaming at 11 a.m. For the next 3 days. So it's going to be a morning stream. So hopefully some people in some other time zones can catch up using our holiday hours. They can actually come to the live stream, which, you know, if this was airing in the middle of the night where you are, you didn't have the opportunity yet. So hopefully we'll see some new faces too a little bit in the morning stream. And the other thing that I wanted to point out is that we should have, hopefully sometime soon, at handmadehero.org. If you go there, obviously, you can still do the standard stuff. If you want to get the source code, you can pre-order. If you want to get to like the Twitter accounts or any of the stuff, quick links are all right here. But soon, very soon, hopefully maybe later tonight, maybe tomorrow, this email a question button should hopefully turn into a forums button. We are trying to get that working. We are wrangling some ornery Joomla and other nonsense to get sort of a forums wiki thing up and running. It'll be a little janky, but at least there'll be a place for people to go and congregate, because I know that a lot of people will be asking about that and asking for places where they could sort of store all the information and make a nice way that it could all be linked and worked on. So we're working on that. Hopefully we'll have that up sometime soon, hopefully by tomorrow. So thank you everyone for joining us, and now let's take questions. Please be sure to put @CMuratori in the question somewhere so that I will see it. Because I have a little filter that only shows those for the question for the Q&A part of things. let's take a look. Oh, yes. Okay. You guys totally caught this. Thank you. Much like I said we had to rearrange these, Microsoft again did them in exactly the wrong order, so you're liable to make that mistake. I don't know why we didn't get a warning. Oh, because we initialized it to 0. I guess one thing that might have been smart to do was that first, because if we had done that first, even though we want to clear it to 0, it would have told us that that was uninitialized, and we could have moved it up here. So that probably would have been a little bit smarter, come to think about it. I don't know, was that the only bug we had? That would be amusing. Holy cow, dude. That was it. So just me misplacing the structure thing, that was it. And the stream caught it. How awesome is that? Boy, I tell you, programming with a stream behind you is pretty awesome. You make a little error like that, and you might have to go hunt for it for a few minutes and be like, what happened? And I stepped through and look at it. Like tomorrow when we stepped through, I would have had to go through every line and look, and then like, oh, right, it's wrong. Here you just go, the stream just nails it. So this, again, just to underscore this, when you're making an API, don't do stuff like that. You're just, setting yourself up for failure. You want to initialize the variables in the order they appear in the structure. Don't stick variables, down somewhere and then tell the user to use them in a line that happens before that member. You're just asking for bugs. I mean, help the users out, right? Like, help them succeed if you can. Don't set them up for failure. It's a simple bug. It's only going to take a few minutes to fix. It's not a huge deal, but why would you do it? Why? Yeah, it doesn't really make much sense. But that's pretty awesome. Thank you, Stream, for catching that. It looks like now we're initialized properly, so that's pretty awesome. That was the only bug we had in that whole thing. That was great. Awesome. Let's see. Do you use any data structures while making a game like linked list binary trees? Sure, we will be using data structures all over the place, but wait till we get there. Let's see. Trying to look at questions on the code as we did it. What keyboard do we use DOS keyboard for? You're going to have to put up a FAQ on the keyboard. I get so many questions about that. As well as these. They're Medi-active wrist braces. I don't know if they still sell them. Can you explain again why you need 2 buffers instead of just doing everything in one? Yeah, I can't, well, okay. I can't really explain it. I can say the words again. But really the explanation is because Windows is weird. That's kind of more the real answer. But the explanation is because one of them is creating a buffer. The other one is really just getting a handle to the actual sound card in some sense. That's really what, in theory, is more like happening. So basically this right here where we create a sound buffer, the second quote-unquote secondary buffer, that's actually our sound buffer. That is the buffer into which we will actually write things, okay? So that's the thing that creates the buffer. This thing up here is a strictly optional, perhaps entirely anachronistic at this point, thing that you used to have to do in order to make sure that this buffer actually played out the sound card without getting resampled. So in the old days, the sound card used to be playing at a certain sample rate. So basically, the sound card might be set to 44.1 kilohertz, or it might be set to 48 kilohertz. And if you were trying to play your sounds at 48 kilohertz, while the sound card was set at 44.1 kilohertz, it would always go through a resampling, which makes it sound worse, and it's waste time, right? Now, a lot of that stuff isn't true anymore. I don't even know these days what the typical sound chips do. I've never even seen anyone discuss it. I'm not sure. But basically, for back in those days, so the way that you actually told Windows, I need you to set the sound card into this format that I'm going to be using to play sound, was to call this create sound buffer call, ask it for the primary buffer. So it's essentially returning you a handle of the primary output device. Then you just call setForm on it to say, hey, I'm setting the format of this primary buffer to the wave format that I know I'm going to be playing. That's all this buffer is. It's not actually a sound buffer. We're never going to touch it. We're never going to ask it a question. We're never going to send it data at all. It's strictly getting that handle so that we can call set format. That's it. So really, it's this secondary buffer down here is really the only buffer And you'll see that's the only thing we'll ever call. Tomorrow when we actually output some sound, we'll just be calling lock on that buffer, writing into it, and then letting it go. That's it. Let's see. What's the command to compile on your Emacs configuration? Alt-M. Are there any cases where we would want more than 2 channels? For this game, no, because it's a 2D game. So I don't have a full-time sound guy or anything, so we're mostly going to be having stereo sound 2D game. But you could imagine if you were doing a more a 3D game, like and not just 3D, but immersive 3D. So you are in the world looking around, like first person or something. Then you may want to output more channel sound because for people who have those crazy setups, like the Dolby 7.1 or 5.1, like those sorts of things where there's lots of speakers all around, you can actually output stuff to all the different speakers, I believe. For example, when you use the Miles sound system for like the Rad Game Tools product for that, they have a bunch of stuff in there for targeting 7.1 sound and that sort of stuff. And it's not particularly useful for a 2D game, but it could be for like an immersive game where you're trying to play sounds that are like surrounding the user in a meaningful way so they can hear, oh, the gunshot happened behind me, I got to turn around, or that sort of stuff, if that makes sense. So you do want more than 2 channels sometimes. For us, we're not going to really have any data that we can actually make use of it, but there's nothing that says that 2 is the right number. 7 might be the right number for for whatever purposes, or 8. Let's see. If the frame rate would ever drop, can there be audio dropouts? Yes. So here's 2 things about that. I snuck it in there and I didn't really describe it. Let's go back to, well, I can't because I closed the GIMP diagram. So you remember when I draw the awful GIMP diagram that hopefully I'll fix. Well, I don't know how we're going to do it. Maybe after the stream ends today, we'll just leave the stream on and I'll play with the settings. We'll start the stream, stop the stream, start the stream, stop the stream until we actually figure out how to get drawing properly. But basically, the reason I was saying we're going to make a big buffer. You notice I said a big buffer. I said 2 seconds. Well, why would you want the buffer to be 2 seconds? It doesn't make any sense, right? Well, the reason is because audio dropouts, there's 2 ways that you can kind of approach them, right? One way you can approach them is writing way ahead of where the game is. But then you've got a lot of latency or you've got a lot of overwriting that's going to happen, one or the other. The other thing you can do is set yourself up so that in general you only write maybe 1 additional frame ahead. So if you miss 1 frame, you're fine. But if you missed a lot, you'd skip. But instead of it doing what normally happens, where it's the audio dropout that you hear, where you hear the it's going like like that thing that you can really hear the when it loops really quickly. That's because they had too narrow of a buffer, so it was playing the same 800 samples or 1600 samples over and over again, which is immediately audible to the ear as a bad sound. You're like, oh, it dropped out. If you have a 2-second buffer, you can actually just full-on stop sending samples. And the stuff that's in the buffer is whatever happened for the past 2 seconds. And you'll get a little bit, you could sometimes notice if there was like a big thing, like an explosion happening or something that happened right there. Maybe you'll hear that jump in suddenly. But you won't actually hear any objectionable things. It'll actually stay smooth and just sound like you were still playing from before until you come back. And so one of the things that I found is very effective is always have a giant buffer. Because then even if your game gets just hammered for some reason, there's a disastrous, the CD-ROM drive opens and Windows halts your process and whatever else, you'll still actually be fine. It'll sound fine. You can play forever on that 2-second buffer and there'll only be 1 skip point and it won't really be that noticeable. So it's just a little trick and something that we did. You'll see it later. Let's see. The real silliness is that n block align and average byte per second are redundant. Yes, that is true. Oh, that's John. Hello, John. John says that n block align and n average bytes per second are redundant, and that is true. Basically, you have to kind of wonder a little bit If this is something that the documentation basically told you to compute, why don't they just compute it themselves? And I don't know. That's a good question. I assume that it is there primarily because they wanted to support extended sound formats where this wouldn't necessarily be true. But again, maybe they should just let us pass 0 in that case. Maybe they do, but it wasn't documented, so they could just let us pass 0, and then we wouldn't have to do all this ridiculousness. To be honest, this, like, I don't even know why this is here. I mean, it knows the channels, it knows the bits per sample. None of this stuff should have to be filled out. You should be able to set it all to 0. So I don't know, maybe you can, maybe you can't, but that's just dumb. Well, we kind of know you can't because we accidentally set one to 0 and it didn't work. So it should have just let us do that. It is just dumb, and John is correct. Let's see. Let's see. On Linux, will we be doing ALSA or higher level like Pulse Audio Jack? So I don't know. Probably just ALSA because that works on the most platforms, and all we need is one output stream. But we'll see when we get there. I'm not a Linux platform expert, so probably I will consult some Linux platform experts, and I will get their opinion, and we'll just have to go with that because I have not shipped games on Linux. I mostly have it running on Linux for my own development purposes. That's why I usually run on Linux. And so I feel like my ability to really judge that would not be that good. So I will probably defer to some people who have had a lot of experience with that. I'll probably ask some of the Valve guys who did Steam Linux, who are friends of mine, to basically, give me what's going to be the Steam Linux path. That's probably what we'll do on Linux, in the hopes that that sort of initiative will kind of get some momentum next year and maybe get some more Linux gaming happening. That'd be my preference. Just do whatever Steam Linux wants done. What newer sound API would you recommend instead of old DirectSound? I don't know. DirectSound is totally fine for my purposes. I like to do all my sound mixing myself. I don't know. So I've heard people say X Audio is the thing that people use now, but I don't know. Yeah, I feel like X Audio is probably it, but I'm not sure. I don't do any programming in the newer sound APIs, so I'm not really in a position to say whether they're good or bad ideas. It may be that they're just more work than to do, and why bother? But it may be that you get better latency and that sort of stuff, and then it's worth it. I'm not sure. Let's see. What is a... Let's see. The 2-second buffer doesn't sound acceptable, not noticeable if you're playing music. I found that it did. I found that it was most people did not notice, at least on Sushi. It worked pretty well. It's not, again, it's not what you want to have happen. Like, you wouldn't choose to have your audio drop out ever. But compared to the repeating sound, which is harsh and awful, it's much better to have it do this way. And I found that it was actually very difficult for people to tell, especially while they're playing and not paying super close attention to things necessarily. Let's see. Have or do you work in the industry? Yes, I do work in the industry. I have worked in the industry since I was 1995. So since I was 18, and I've been in the game industry ever since. Don't know that I necessarily recommend it, but I was. Let's see. Have I thought about guest programmers tagging to teach things like Linux or whatever topics their expertise? I have thought about that, and I do like that idea. The only problem is I don't know how practical it actually is. At the very, very least, we will certainly get expert opinions on things as much as I can for areas where I would prefer someone who's more experienced at it, at that particular thing. We will certainly get that before we do whatever we're going to do. Whether or not someone else will actually stream, I don't know. But definitely something to think about. Let's see. I think that is it. So there's one other thing I wanted to talk about that I forgot to do at the beginning of the stream. Since there doesn't seem to be any more questions, I'm going to go ahead and actually look here at the thing that I wanted to double check. So someone pointed out that this mem commit here in the virtual alloc, someone pointed out that this actually probably should be both a reserve and a commit. So if you pass mem commit to virtual alloc, it will reserve and commit the memory for you at the same time. But technically, apparently, that's not really correct. Like, it does it, and it works, but you're technically supposed to do reserve as well. And apparently, there was a post by Raymond Chen that said that this was a thing. And so, if Raymond Chen says it, it's probably true. I mean, the dude knows Windows better than probably anybody else in the world. So I'm going to say that's probably true. So we probably want to do that if that is the more correct way. Like I said, it doesn't actually change the behavior as far as I know, but it's worth noting that that is probably a little more correct than just saying mem commit and having Windows do the right thing anyway. I thought you only had to pass commit, but I guess you actually more technically should tell it to do reserve and commit explicitly. So just something to think about. That was basically a question from the previous stream, and someone wrote in and was basically saying, I don't think so, and here's a Raymond Chen thing. And if Raymond Chen says it, it's probably right. So I would stick with that. Like I said, don't think it'll actually make a difference, but just you might as well be more correct if you can be, just in case there's some edge cases where it actually does matter. Let's see. Looking through here. Why wouldn't you recommend game programming as a career field? I'm not saying I wouldn't recommend it as a career field. I'm just saying it, you know, it's like anything else. It has its pluses and minuses. I do like a lot of aspects of game development, but at the same time, it makes you a lot less able to play and enjoy games. Like anything else, the more you see how something is made and the more you become critical of various aspects of it, the harder time you have enjoying a game. I mean, if I think about the games that I enjoyed when I was 16 and I think about how much I would say that they sucked today, I think a lot of that has to do with having been in the industry and thinking critically about games for a long time and their implementation and all this other sort of stuff. I feel like that's just something that happens when you get into it. So if you're someone who really enjoys games, the answer is not always, well, if I really enjoy games, I should go make them. That's not necessarily always true, right? I mean, if you really enjoy chocolate, it doesn't mean you should be a chocolatier. You might just be someone who really likes chocolate, and you should go do whatever you find that you enjoy doing for money, and then buy chocolate. But, you know, like I said, it depends. If you really like technical things like what I'm doing here, and you like the sorts of things that we're doing on the stream, then you probably would like game programming quite a bit, and then you should be in the game industry. And if you like the sorts of things we're doing on the stream, you'll probably be very good at it, because these are the sorts of things that basically only detail-oriented people are going to like, and people who enjoy intellectual curiosity, only those sorts of people are going to like the things that we're doing on the stream. So if you find yourself gravitating toward it and thinking it's cool, if you thought it was cool that we drew our own buffer before, you are probably someone who would enjoy game programming. It's one of the few programming fields left where people actually care about that sort of stuff, and where it actually does make a difference in the quality of the game if you know how to do advanced things and get better performance and so on. You will be very valuable to an engine team somewhere if you know these sorts of things. And that is not true in a lot of other disciplines. A lot of other disciplines are very lax in terms of performance, very lax in terms of resource consumption now compared to games. And truth be told, the reason that it's that way in games is just because games have to perform at 30 or 60 frames a second. They can't be lax with those things. They have to fit in limited memory on consoles. They have to do these things. And since they have to, they do. And so that's just the way it goes. Let's see. Will we show how to use bone animations, or will we use sprite sheets? So bone animations and sprite sheets are not mutually exclusive. That is a slight that is a question that presupposes an answer that isn't actually necessary. You can have a sprite sheet that has a bunch of pictures on it, and then you can assign bones to those things that will manipulate the sprites in the sprite sheet. If you mean will we use bones to animate things rather than strictly using direct copies, I have not 100% decided yet. We will probably support some sort of bending, depending on how we end up doing the renderer. It's really about the renderer there, whether or not we support that. So it remains to be seen, but the answer is probably going to be yes. Will we preload all the audio files or stream from disk? We will stream from disk. Do I count between taking drinks? It seems to be on a certain timing. No, I do not. It would be interesting if it was a timing. It's just when I get thirsty. Speaking of which, is there a name to the double buffer technique? I still don't understand the concept and want to do further reading. The double buffer technique. Are you talking about the primary secondary buffer thing? If so, I just want to emphasize again, it is not double buffering. We are not creating two buffers. All this buffer call is doing is getting a handle to the primary sound device so that we can set its format, which puts the sound card into a mode that allows it to play in the format we want. That's it. This is not a buffer. Not a buffer. Do not think of this as a buffer. Think of it as a handle to the sound card. It's purely old incantive stuff that we're doing here. Just telling Windows, this is the sound format we want to play. That's all we're doing. There are not two buffers. This buffer is not really a buffer. We will never use it as a buffer. Let's see. Are we going to get into concurrent programming? Yes. Do we think we'll use any of the kinds of meta-programming stuff I do these days for this project? Probably not. I don't think we will have time to really get into that sort of thing. Maybe we will a little bit, but I don't know. Let's see. How much do optimizations matter in game programming? Is it mainly about making the game work, or do game programmers also worry about optimizing the game for the hardware during the development? Not sure I understand the second part, but optimization matters a ton. Basically, like, either you optimized your game or you wrote on top of an engine which was optimized and does a bunch of work to optimize for you. But optimization matters a lot. I mean, you know, try to run the original Binding of Isaac on a laptop and the thing is like super slow, right, or whatever. And that's an example of what happens when you build something on top of something that wasn't a game system, that wasn't optimized to do what games do, right? It's Flash. Those sorts of things, you know, you get this all the time where something is not fast enough and totally should be. Computers are very fast these days. They're certainly fast enough to run any 2D game we probably might want to write. And so you really do have to care about optimization in a lot of cases. Now, there's some code that doesn't have to be optimal. Well, none of the code is going to be optimal. There's some code that doesn't have to be optimized because it just doesn't get executed enough to actually warrant it. But a lot of the code, certainly the renderer, probably some of the sound stuff, depending on the circumstances, and probably some of the entity updating stuff and physics and that sort of thing, depending on how many entities you have, do need to have some serious optimization done on them oftentimes. And again, sometimes that can be an engine can help you with that. It's not perfect. Like, you know, a lot of times you'll actually have a situation where scripting is taking a ton of the time in a game, and the engine can't do that much about it. There's actually a lot of initiatives, I think, with Unity and with Unreal. Like, Unreal just switched to compiled scripts and things like this, like to actually, you know, I think they actually compile in C now instead of having a scripting language or something like this. I don't follow that stuff, but point being, you do actually get in circumstances where actually the game code is the problem. The higher level game code that's just saying what entities do and that sort of stuff actually is causing performance problems. So at all levels, you kind of do have to think about that performance. Games, by their very nature, are about responsiveness, low latency, these sorts of things. And so you just can't have piggy code sitting around because it'll bite you sooner or later. Why don't we use the second buffer to grab the handle instead of creating something just to grab the handle? It's because of this flag right here. Basically, Windows either returns you a buffer you can use, which is what we do down here, or it returns you the magical special handle to the primary buffer if you pass this. So we need to set the format on the primary buffer to tell the sound card what format it should play in. So that is what this is doing. It's saying, hey, Windows, give us back the special secret awesome buffer so that we can set the format on it. It says, okay, here it is. We set the format, we're done with that buffer. Then we say, okay, now give us back a handle to an actual buffer we can actually use that has nothing to do with the primary buffer, and then that's the one we can actually write into. There's no rhyme or reason to this. It's just legacy in some sense because basically you used to actually write into the primary buffer. The first version of DirectSound, you wrote directly to the sound card, so there only was a primary buffer. And secondary buffers were for doing things like sounds that the primary buffer would use to stream in. There was actually a little more logic to it. Now it's completely banana cakes. Really all you should have is a call on DirectSound to set the format. That would make a lot more sense. So this is just kind of busted, but it's still the way it works. And I know it's a little hard to understand because it doesn't make a lot of logical sense. That's just the way it works. Is there some way of figuring out how many CPU operations we have available per frame and optimizing the game code based on that number? Yes, and that is exactly what we will do. But wait till we get there. Let's see. Isn't this learning how to carve stone using a chisel over using modern machinery? No, because basically right now we don't have modern machinery. One of the things I said in one of the other streams, someone said, why reinvent the wheel? My argument is we don't have any wheels right now. I don't think game engines today are very good. I'm not trying to disparage the people who work on them. I think they probably do an excellent job for what they are trying to do. But we just don't have the technology right now to actually write the kinds of things that we want to write for building games. So I think we have a long way to go to actually build the tools we need to make game development so that there isn't any reason to ever do this low-level code again. So basically what I'm trying to do with this series is sort of show a new set of programmers how to do this low-level programming, because without more low-level programmers doing this kind of programming, we will never build the actual tools we actually need. Like, we are so far from being done building modern machinery, as the term you used. Like, for example, just to put it in complete analogy terms to what you said, it's like you told me when you developed the horse and buggy, that you're like, why are you teaching people to study how to build like axles and like gear rings and stuff? We have a horse-drawn carriage. It's perfect. You're like, dude, we need like airplanes, okay? We need race cars. We need trains. We need rockets. Like, we're not anywhere near there. So don't pick up a game engine and think you are using a rocket. You are using a horse-drawn carriage. And what we need to get to over time is we need to get to the rocket. We need to get to the race car. We need to get to those things. So someday, yes, that will be an okay mentality to have. Why reinvent the wheel? Why not use modern machinery? Someday. We are nowhere near that day. We are not even 10 years from that day. We are like 50 years from that day if we're lucky. So I think it's imperative that we get a whole new generation of programmers working at the low-level stuff so that they will be writing their own tools, they will writing their own engines, they will create the next Unities, they will create the next Unreals, they will create the next Source engines, and we will keep building better and better things so that the people who don't know how to do this stuff can use them, and so that someday we can put this to rest finally and say we pretty much got this under control, we're done. So that is the end of the stream. I think that's about it. We are at 9:30 and that is the end. Thank you so much for joining me. Hope to see you here tomorrow bright and early in the morning, 11 a.m. I hope some of you will be up for that, and maybe we'll be getting some people from different time zones, so we'll see some fresh faces in here. That'll be great. Again, as always, you can go to handmadehero.com if you want the source code. You can pre-order. If you want to ask a question, you can use the email question button, and hopefully that'll be forums sometime very soon. Obviously, there's the Twitter feed you can subscribe to. If you want to see the schedule, I usually tweet several hours before the schedule and 1 hour before the schedule just as notifications. And you can click on the live button, but you're already there watching on Twitch, presumably. You can click on that live button if you want to follow on Twitch, so that you'll get email notifications when the stream goes live. Thank you so much for joining me, everybody. It has been a pleasure as always, and I will see you tomorrow morning when we will actually start playing some sounds out of our sound buffer.